sorry, let me start that again. So the common misconception for this class is that game scripting means that I'm going to teach you guys to, like, creatively write a script, insofar as you're going to write the story or you're going to write something. However, when we talk about scripting in the gaming world, generally what we're talking about is programming. So for some of you, that's terrifying. For some of you, you're like, okay, let's just get this done and over with. For a mass majority of you, you're like, it's 9 a.m. Why is there a class at 9 a.m.? I agree with you. I don't like morning classes, but this is the hour that this class was assigned, so we're gonna struggle through it together. So the first thing I wanted to kind of go through was how this course is going to work, what it's going to look like, what you're going to need, all that kind of jazz. If you haven't been in Canvas, if nobody's walked you through Canvas before, I kind of wanted to go through that as well, because sometimes people don't know about the hidden tools and things like that in Canvas. So when you go to Canvas on a web browser, the first thing that kind of comes up is this dashboard, which has your courses that you're currently enrolled. It'll have a to-do list, which is like, hey, these are the things that are the most important things to do. These are the things that are due the soonest. For me, mine's a little bit different. Mine are what I need to grade. But it also has like a coming up, which will show you what's coming up in like the next week or so. Now, you may see this little button that says View Calendar. Your calendar is one of the most helpful things that nobody ever talks about. As long as your professors have put all of their dates in for due dates, if you click the calendar, it will show you everything that needs to be done, things that are already closed, things that are still open, when things are due, that kind of jazz. And you can even come over here and say, hey, I don't want to see one of my classes, I only want to see the other class. So that's ridiculously helpful. It's, if you guys are calendar people, it's great. So if you're in your dashboard, all you have to do is click our class. If you are on the browser, it will automatically open to the syllabus. If you're on the phone app, it will take you to modules instead. Why? I don't know. Why is it so hard to find the syllabus on side of the mobile app? I don't know. The wonderful worlds of technology. So, yeah. So as you can tell, we're using Discord over Zoom. That's because Discord's better in like every way. I just generally do not like Zoom. I don't mind using it. If I have to, I will. However, it's got a lot of security issues. It's got a lot of bloat to it. Because I generally tend to teach courses that are a little bit heavier software-wise. So, like, Maya or Unity. I like using Discord over Zoom because it is less heavy, or it's more lightweight on your system. That, and I like, one of the things that everybody likes about Zoom is the fact, oh, you can see everybody, you can look at your students' faces. It's a 9 a.m. class. We are all home. Probably 90% of us are in pajamas. Oh, no problem, Danielle. I get it. I 100% get it. I'm willing to bet that 90% of us are sitting around in pajamas and being like, oh, thank God there's not a face cam. I don't need to see what your life is about. You don't need to see what my life is about. All you really need to do is see what my screen is going to say and hear my voice. So, that's kind of my spiel on Discord. It's also so much simpler, like, as far as everything goes. So, yeah. So, for this course meets Saturdays, 9 a.m. to 12:30. Again, I'm sorry about the time. Modules are the best place to find out, like, how this class is going to work, and we'll go through those in a little bit. Best way to contact me, those of you who have had me before know that I am always in Discord. Like, pretty much always. So, if you want to message me through Discord, that's probably the fastest way to get in touch with me, but you can also email me or Canvas mail me. I give you my cell phone. Please don't blow up my text messages. Please don't call me, please. I mean, if you have to, like, if it's a final, like, last resort kind of thing, you've got to get in contact with me, you have my number. if you do contact me, please let me know who you are. Don't just be like, text message, yeah, I'm in the hospital, I have to miss class. I'm gonna be like, okay, this is cool, but who are you? Yeah, it takes effort for me to find out who you guys are if you send me something without a name. As an adjunct, I don't technically have office hours because I'm not paid for office hours. Um, that being said, if you need my help, one, I tend to be available if I haven't decided to go take a nap after this class. I'm available the hour after if you let me know. But also, you can ask the other people who have taken me. There's a few of you, there's a handful of you who have taken me now, or who are taking me. Can also tell you I'm always in Discord. So if you ask a question inside of Discord, there's a good chance that I'm going to see it and get back to you within an hour or two. Generally sooner than that if I'm not like actively doing something different, like, playing video games or working on, because I work for a small studio, so I do have, being a professor is not my only job. I wouldn't be able to survive if it was my only job. Yeah, we don't get paid well. Just in case you ever needed to know, we don't get paid well. So yeah, Discord is definitely... The other nice thing about Discord is, since you guys are all here, if you ask inside of Discord, there's a good chance that somebody else is going to be like, oh yeah, I'm having that problem too, or oh, I know the answer to that, or here's this really cool tutorial that talks about that. So you can kind of find whatever you want. Even though our class is 9 to 12:30 and we are on Discord, I do record all of our sessions, so if you ever need to go back to it, or if you ever have to miss it, or if you ever sleep through it, because there will be at least one day that you will, if you're not a morning person, and I get it 100%, you can just go watch the recordings. I don't take attendance. The one nice thing about being in class is that you can ask questions more easily. That's the one big thing. That, and you get to suffer with the rest of us at 9 a.m. So, that being said, I am definitely more of a night owl than I am a morning person. A lot of the people and a lot of the companies that I've worked with in the past are on different clocks and across the world, so yeah, there's a good possibility that if you email me thinking, yeah, she's never going to see it at like 4 o'clock in the morning, I am going to email you back, like, right away. So don't be surprised if you try and ask me something at a ridiculous hour and I answer back immediately. Honestly, it's more likely that I won't answer something if you email me at like 9 a.m. or 10 a.m. because there's a good chance that I'm sleeping at that point. Minus this class. So what to expect from this class? Like I said, we're talking coding, scripting languages, programming scripting languages, not like creative writing, making things sound nice. So we'll be looking at DOS scripting. If you have a Mac, please let me know. If you have a Mac that doesn't run Windows, please let me know. Yeah, because that'll be interesting. I may just change the assignment if that's a thing. So we'll be looking at Lua, and we'll be looking at Python. On the schedule, if you guys have gone through the modules, I do have a section where we might look at phaser.js, which is a JavaScript library that works with HTML5 to make online games. But that's only if we get there. If we have to push things around or change things up, that's the one lesson that can kind of get yeeted off the face of the earth and be fine. So just note that this class is pretty fluid. This class also tends to be there's a lot of like upfront work learning the engine and getting a crash course in the language, and then you guys get a few weeks to play around and to make a game. And yeah, so there's a lot of lab time, so there's a lot of free time for you guys to do what you want to do. I may institute checks so that I can for sure make sure that you guys are working on stuff. I don't know yet. I haven't decided yet. Because generally my approach is you guys are all adults, so you're going to work on what you need to work on. Sometimes that works, sometimes that doesn't. And so make sure that you're checking Canvas, and make sure that you're checking Discord. Generally, I will post in both if there's something like super important, but a lot of times I'll just like throw a hey in Discord to be like heads up or something like that. It just kind of depends. Yeah. Okay, so I will probably throw in checks, and they won't be worth a lot of points, but they'll be worth some just so that I can make sure that you guys are working on things and working towards things. So yeah, so required materials for this class. Some of you and some people in the past have panicked because there is no textbook listed, there is no anything listed for this class, and that's because there is no textbook. We don't use Pluralsight, so those of you who have had to get Pluralsight for other classes, we don't use it. We don't use any kind of textbooks. What we use, and the only thing that we use basically, is we use a program called repl.it, and it's not really a program insofar as it's a website. So repl.it, and it's this kind of, oh, why am I locked out? Okay, so it's this kind of cool program that has like 50 different languages already built into it, so it's an IDE. So those of you who have used Atom before, it's sort of similar insofar as you basically just create a new REPL, and it gives you the option of, I mean, so many languages, and it's all built in for you. So you don't have to install new IDEs, you don't have to worry about installing the languages, you don't have to worry about installing libraries because they're already built in for you. And it's cool, and it's great, and yeah, you guys may, those of you who are really enjoying programming, or those of you who want to take your games to the next level that you're going to build, 100%, you may want to download Python, you may want to download Pygame, you may want to download Lua and the Love Engine, and that's fine too. But I wanted to give you guys a place that you didn't have to worry about installing or worry about things like hooking up to each other. It works for the basic stuff. It can sometimes be kind of choppy, but it works for what we need it to. So it's going to be up to you. When you actually turn things into me, they will always have to be a REPL link. REPL also hooks up, for those of you who are tech savvy, REPL will hook up with your GitHub so that you have more space, because by default you've got a very small amount of space that you can have like images and stuff like that. But if you hook it up to your GitHub, you can put all the images on your GitHub, and then your GitHub can talk to your REPL. So it's a really cool place. Yeah, I definitely highly suggest it, especially if you're trying out a new language or you're doing something like this class where there's a good possibility that none of you will ever touch, especially Lua. None of you will ever touch Lua again, or a good majority of you will never want to touch Python again, because I'm pretty sure most of you, this is not your kind of wheelhouse. There's a few of you that are programmers, or that are programmer savvy, that maybe will want to play with this later down the line. But I hold no delusions that for probably at least half of you, this is the class you were dreading. 1, because it's 9 a.m., and 2, because it's more coding and you thought you were done after your intro class. I get it. Code can be a thing. It can be a thing. So yeah. Suggested is a microphone so that you can more easily ask questions during lecture, but it's not required. I have multiple screens, so I do have Discord up, so I do kind of watch and make sure and see if anybody's typing. And then the one weird thing that I suggest is graph paper. And you can make your own graph paper, like you can draw your grids and everything, because the point is that eventually down the line, as I closed it, we're going to get into drawing things. So, no, my REPLs. So what we're going to end up doing is, let's just go to this one, Pygame. That's Pixel Draw, Pygame Draw. So what you'll end up doing, and Lua will be a little bit less crazy. I mean, Python, you definitely don't have to be this crazy. But you'll end up plotting points. If you guys ever drew things on your graphing calculators when you had graphing calculators, you're gonna draw things for like to understand how the programs work, how our engines work. So this was done in Pygame and Pygame and Python, and like you have to plot points to draw things. So that's what graph paper is great for, because you can kind of draw it on the graph paper, and then you can figure out from there your dimensions and your points and things like that. So again, it's not required by any stretch of the imagination, and there's only like 3 assignments that it would be helpful with, so don't go out and think you have to buy graph paper. Generally, I supply graph paper, but as we're not like meeting, can't really do that. So, rules and expectations. Like I said, check Canvas, check Discord. Try and complete assignments on time for me. I do tend to have about a week grace period for small assignments. For like your big, you have to turn your game in, you have to critique your games. Those are due on time. If they're not, bad things happen. Otherwise, you have about a week grace period. I don't tend to take points off for late work, but if you're habitually late, I will. Let me know if something's happening in your life, or I know a few of you, or a couple of you, I think, are taking game sim, and I know that can get super crazy, or maybe you suddenly went from working 40 hours at work to 60 hours at work. Let me know what's going on in your life. If you can't get something done on time, let me know. I treat you all like adults, and part of being an adult is knowing when you just can't get things done. Yeah, time management is a big thing, and I will be like, you need to manage your time better, but part of that and part of being an adult is also knowing when to say, hey, I can't do this, I need help, or hey, this deadline's not going to work for me. So just let me know, talk to me. Like, literally talk to me. You can talk to the people who have had me before, and they'll tell you I'm pretty forgiving about that kind of stuff. So just let me know if there's something happening. During lecture, if you're eating, especially if you're eating, or loud sounds, mute your mic. Otherwise, I don't care. If I can hear a little bit of music in the background, okay, that's fine. A TV playing, okay, cool. There's a good possibility, although I will say I don't think either of my classes, my level design class from last semester or my modeling and rendering 1 class from summer, got to hear him. I do have a basset hound, and if you don't know what they are, look them up and look what sounds they make. He can literally make the house vibrate. For such a small dog, I mean, they're not small, they're medium breeds, but for such a small dog, you can hear him like from one to the neighborhood to the other kind of thing. So he's very loud. When he wants attention, he is ridiculously loud. So that may be a thing on my part, and so I will apologize ahead of time in case it does happen, because there's a good possibility it will. I say every time, and then it never happens. So because this is a coding class, I do suggest that you guys, if it works good for you to code along with me, code along with me. If it doesn't work for you guys to code along with me, just watch, wait, listen. I tend to give, if I have an assignment in the morning, some of them that are in-class assignments, they're due at like midnight, but again, like I said, I've got some grace time, so don't worry about if you just can't get it done in time. So yeah, code along if that works for you. If it doesn't, just watch. And then this is like my new pet peeve, because I had somebody over summer that did it habitually. Please don't play games during my live lecture. Or if you are playing games, do it in a stealthy way. Like if you're sitting with a Switch and you're playing a Switch, okay, cool. I will never see that. The issue is when I can see it. So with Discord, those of you who have not used Discord will display a message of, by default, what game you're currently playing or what game you currently have active. If you guys have checked out Discord, in the past week, you've probably seen me like 90% of the time on Final Fantasy XIV. So if you're playing a game during my lecture and you haven't turned that setting off, I can see it, and it makes me sad. If you still want to do it anyways, go and turn that message off, so at least I don't see it and I can be blissfully ignorant. Because I know half of you are like playing something else or reading Facebook or doing, you know, everything else. I get it. It's an online class. It's early in the morning. Nobody actually wants to be here. I mean, I do. I actually enjoy this class, but I definitely don't enjoy this time. So when it comes to actually working with the code and the scripts, save often. REPL does have an autosave function. And last semester I only had one person who had an issue with it, but holy heck did he have an issue. To the point that he would lose hours and hours of work because he was just relying on the autosave. So make sure you save, and save often. Give files names, like, give them names that make sense. Same with variables, things like that. Follow standard naming and coding conventions. It never has to be something that's like, this is set in stone, this is what you must do. But as long as you follow, like, whatever your personal naming conventions are, make sure all your variables are kind of named the same. I'm happy with that. So this one's not going to really be much of an issue for you guys, especially for when we're using REPL, because REPL will just link me. You'll send me your REPL link. But generally how I want them is your last name, your first name, and then the name of the assignment. Or a name that's similar to the assignment. Turning in assignments. Again, generally you guys are just going to send me REPL links. The one exception to this is when you finish, because you'll be doing a minimum of 2 games for this course. One in Lua, one in Python. If we get to JavaScript, you'll have a JavaScript. And then for your final, you take one of the games that you've built. Oh, I guess, and you have a text adventure. But you'll take one of the games that you've built and you'll work on it to, like, polish it and make it better. Or you can create a brand new one if you really want to. But what I have you do when it comes to, like, submitting those is that you have to submit a video with it of you playing it and kind of presenting it. And when I say it needs to be a video, I'm not going to grade you on videography. I'm not going to grade you on it being, like, the most beautiful thing you've ever done. If you don't have screen capture software, if you don't feel like getting something like OBS, hold your cell phone up and take a cell phone video of your screen. That is acceptable. I just need to be able to see you playing your game. That's it. So that's the one thing that will be, like, a bigger file as far as that goes. But so, yeah, make sure to turn things in on time. Things that aren't excuses are slow upload speeds, because I have the slowest upload speed. Internet going down at home, and I get that. I really do, but let me know ahead of time. Forgetting to submit the assignment, again, you have about a week grace period, so don't worry too much about it. Really, the only one I'm going to harp on is this idea that when I open a file, it's somehow corrupted. I know the trick of corrupting files to give yourself extra time. I grade relatively quickly, within a week generally of what's been turned in, so you don't get that much extra time. And I have that grace period for you to work on it, so I would rather you not submit something and turn it in late than try and trick me with a corrupted file. Like, that's it. That's really what it is. Yeah. So down here, this is a course summary kind of thing. If you scroll all the way down to the bottom, and mine's got a few extra things in it, so don't worry too much about that. It's going to have a couple things that are ungraded, and those are the JavaScript things because, again, I'm not sure if we're going to get there. I'm not sure if you guys are going to be comfortable with switching to JavaScript based on your pretests. Yeah, I'm sorry. I guess that was really rough for a lot of y'all. I will note that in previous classes, if you failed that pretest, not me, but the professors before me, if you failed that pretest on your first go, you were given 24 hours to make it up, and if you didn't pass it the second time, you were kicked out of the class automatically. So I don't believe in that, because I know some of you, this is like the last class you need. But yeah. So the weight for this class, in-class assignments are 30%, major projects are 40%. So that's the bulk. You need those guys to pass. Your homework will be 20, and homeworks are going to be discussion boards and things like that, as well as any kind of outside assignment. And then quizzes are 10%, because I know nobody likes quizzes. I hate multiple choice quizzes, but I know that that's what lots of people like, so I try and give you guys that. So let's look at our modules, and let's see how those are set up before we get into like today's kind of thing. So the way that modules are set up is that I've named them by week for you guys, so you kind of know what's going to happen. So the one or the two exceptions are these things that are tutoring and academic support and WAC writing space. So you will be writing for me insofar as you'll be writing a postmortem or two. Postmortems are, for those that don't know, they're kind of, after you finish the project, you write about how the project went, whether you liked it, whether you didn't like it, what went right, what went wrong, where you would go with it next. It's those kinds of like a retrospective. So yeah. So basically, the writing lab will help you if you ever need help. And then tutoring and academic support. Our tutoring department does have a Discord, but they do their tutoring sessions inside of Zoom. That being said, you'd have to ask them, but I'm not sure if any of them or which of them are versed in Python or Lua. Python is probably more of a possibility than Lua, but they should be able to help you with basic logic and things like that. Yeah. I'm always mean to ask them every semester if any of them know the languages, but then I don't. If you don't belong to the general Discord for that, let me grab copy. Okay, inside of Discord. That is our 3D game programming tutoring Discord. And I think I've given you guys a link directly to the works in progress, which you can post works in progress if you're really proud of them, but there's also a general. And it is wonderful. It's a good community. So, and it's a great place. They'll always post inside of like rules and guidelines and announcements. They'll post who's working at what time so that you can actually find which tutor is tailored to whatever you're needing tutoring with. Because our tutors have a very limited number of hours they are allowed to work, and so they've got to kind of spread the wealth. Yeah. Tutors are also overworked and underpaid. Before I came to work here as a professor, I worked in the Writing Across Curriculum lab, so the WAC lab, as a tutor over there. But through coincidence and knowing people, I got a job as a professor. And yeah, I'm well qualified for it, if that's ever a question. I guess the other thing, kind of backtracking, a lot of people make a huge deal about the fact that I sound young. I'm not. I'm older than I sound. I'm not a 20-something-year-old, fresh, wet behind the ear kind of person. Yeah. So, anyways, at the end of each week, kind of module, there should be this thing that says homework assignments. And sometimes there's going to be more than... Generally, there's at least one. Sometimes there will be more, sometimes there will be less. This first week is kind of a little bit different, but if we come into the second week, generally this is kind of what you're going to see. You're going to see, or even, let's see, the third week is probably, yeah, you're going to see something closer to like this. You're going to have a discussion board, and generally discussion boards are going to be about project management. So it's going to be read this article and talk about it. However, let's see. Is this one of the ones that has it? No. So for those of you who are program savvy and enjoy programming, you have options for most of these. You can do part 1, which is going to be either read an article or play a game in this case, and then talk about it, or you'll be able to write a program. So for some of you that are more programming savvy and don't give a flying flip about the management side of things, you don't technically have to read any of the management articles. That being said, they are much shorter than the programming assignments. Like, the programming assignments, I tried to make them fun and interesting, but whereas reading or playing the game will take you like 10 minutes, the programming assignments will take a minimum of, I'd say a minimum of 30 minutes for most of them, and that's being relatively nice. Some of them you will have to do, some of them you have an option. So just note that that's a thing. So some of them, some of you will have an option. And I try and be decent on spacing things out for y'all, but I know a lot of things get packed right at the beginning. So, with that said, is there any questions, or are there any questions about how this class is going to work, what it's going to look like, anything like that? Okay, I take silence as a no. Okay, did you have a question? Okay, cool. So, a big majority of you guys have done your programming pretest. Also, make sure to do the introduce yourself. A good chunk of you have. So, 5 of you, so half of you have. Name you like to be called. Pronouns, and I will reiterate this every class I have, I am being serious about that. Because pronouns are important, and if the legal name that your canvas is showing doesn't match the personal name that you go by, and you would like it to be displayed differently for big reasons, not just like, oh, I want to go by my nickname, but for reasons, please let me know, and I can process that change. It'll take some time, and I can't do it, and it will only make it so that other people looking at your name will see a different name. So yeah. Majors, plans for degree, what's your coding experience, because I want to know. And then favorite games and movies, and then your dream vacation. So I've answered all that here for you. I know, as you can tell, probably already from listening to me and looking at this, I write and talk a lot. When I say I have a degree in English, I'm not talking about creative writing. I'm talking about academic. So I wrote textbooks, that kind of stuff. But yeah, and publish on manuscripts and things like that. But I can talk a lot. So we'll go over the programming pretest next week for sure. But we're going to go over a programming review. And a lot of what this class is going to be, and I'm really sorry because this stuff is kind of boring, is going to be PowerPoints, it's going to be slides, it's going to be me talking about the meat and bones of things, and y'all trying not to fall asleep. This class can get really boring until we actually start doing stuff. So, let's talk about programming, and hopefully this will help with the people who bombed that programming pretest. As a side note, for my quizzes, y'all are free to use any kind of reference. If you want to use any of the things that I've written, because I give you guys all of these slideshows. If you want to look at the video again, whatever you want to do, you do you. Yeah, I would rather you not Google the answers, but knowing how to Google and where to find answers to things is actually, for me, and especially this field, almost more important than having everything memorized. Because if you know where to find things, then, you could find them. And for some of you, that's going to be Stack Overflow, which it can and can't be good, but yeah. So programming review, yay! Variables. I'm pretty sure most of you understand variables. They're placeholders for values. So x plus y equals 22, where x and y are variables, and 22 is what we call a constant inside of math. In programming, we tend to declare a type, and then we name it. So int for an integer, a whole number, hint hint for your programming pretest. Float, a decimal number, string, a bunch of characters. And the way that this is written is called Pascal or camel casing, and it tends to be one of the more preferred ways of writing variable names. Again, those of you who are programmers might have a differing opinion on that, but that's okay. That really is okay. As long as you're consistent, I'm happy. So, in programming, we have what are called typed languages and non-typed languages and all of these things. And these are going to be kind of weird. So, dynamically typed, like Python, means that you don't have to declare what the data type actually is. So you don't have to say, hey, employee name is an integer and that integer is equal to 9. What you can do is you can say, hey, employee name equals 9. And it's going to say, okay, I know that's a number, so I'm going to treat it like a number. But then you can also go down and say, later down, you can say, I'm done with it being 9. Employee name is now Steve Ferg. And for those of you who have taken Java and those of you who have taken C++, you're automatically going, wait a minute, that's not how that works. You can't go from a 9 to now it being Steve Ferg. That just doesn't work. Generally, you'd have to cast or do something weird. It just doesn't work. Well, inside languages like Python, it does work. It's like, yeah, I'll delete that other thing and pretend it is never a number. Yeah. So dynamically typed beasts, like dynamically typed languages are ridiculous beasts. Yeah. And a lot of people love them because you can do that. But on the other hand, if you're not paying attention to what you're naming variables, you will overwrite something and overwrite it with, like, exactly how this is, where employee name started at 9, and suddenly now employee name is Steve Ferg, and then you're trying to add Steve Ferg to, I don't know, some paycheck number, and suddenly the answer is now Steve Ferg 99210. And it's like, wait a minute, that's not how that's supposed to work. Whereas we have things like statically typed, which says, hey, you have got to take, and they can't be the same. So employee name is 9. Once employee name is set to 9, it is 9 forever. It's not 9 forever. It's an integer forever. It is a number forever. It says, hey, employee name belongs to numbers. You can't put non-numbers in me. So then when you would go to say employee name equals Steve Ferg, Java will throw a fit. It'll spit out a bunch of errors at you. It'll be like, whoa, that's not how this works. Whereas Python, it's totally cool. Java, C++, if you do some garbage collection, it's not bad. But in general, it's going to throw a fit at you. Meanwhile, we have things that are weakly typed, where... And this is with a lot of older languages, you're going to see weakly typed kind of things where it kind of looks at things. And these, like I said, Perl and Rex, which we won't touch, it'll look for things that are similar. And it's like, hey, so 9 and 9 in quotation marks, which is a string. It will take and say, if you run a concatenation, which is just smushing the two things together, it'll be like, yeah, I totally get that. And it'll also say, hey, I understand that 9 in the quotation marks is actually also a number, so I'll add it as well. Whereas strongly typed languages, which is what we will mostly be using, which is things like Java and Python, you can't straight out concatenate those two together. You can't straight out add those together. You have to cast. So you have to say, hey, I want to concatenate, so I want to smush together A and B. However, I know that A is not a string, so I need to cast it. I need to say, hey, make A into a string before you smush it with B. In the same way that when you would do add, you say, okay, add A, and then take B, which I know is a number, but it's currently looking like a string, and switch it from a string to a number. And we'll talk more about casting later down the line, but this is like a super important part of languages, is whether they're typed or how they're typed. Manifest typed, that's where we implicitly have to say int A equals 9 or int B equals 9. Whereas implicitly is things like Scala and Python, where it's like employee name equals 9. And it's like, okay, yeah, the program already understands that 9 is a number. And I do say number because some languages don't make a distinction between integers and floats and decimals and things like that. Those of you who have had or remember your Java and your C++ know that while we have integers for whole numbers, for things that have decimals, we have longs, we have shorts, we have shorts, we have long shorts, we have, we've got decimals, we've got floats, we've got doubles, we've got all these different things that say all sorts of things. But some languages just treat them all as numbers. One data type. And that's why programming is such a really weird art. Because it really is learning lots of different languages and having to keep them straight in your head. And you will find yourself remembering how you did it in one language and trying to do that in another language and then figuring out that that's not how that works. Because they're languages. They all kind of have a similar thing, but they're going to have different syntax, they're going to have different ways you put things together. If statements are a really good way. Some of you guys have seen if-then statements. Some of you, especially Java and C++, you just see if-else statements. If you talk to older programmers, they will always refer to them as if-then statements, and that's because older languages did if-then-else. And so you always had to have the keyword then in them. And we'll see that with the languages that we're going to use for this semester. So types of data in programming. There are 3 basic kind of data types, which is your integer, your floating point, and your character. Integers are ints, they're shorts, they're longs, they're bytes. What can a byte hold? What can a bit hold? Answer to your programming pretest, it's ones and zeros. That's the smallest, it's binary. That's the smallest part of your computer language. It's what everything is made of, ones and zeros. Unless you get into quantum computing and then you get other things. But we won't talk about that. Then you have things that are floating point. Floating point just means it's got a decimal point. And the ones that we generally tend to think of are floats, doubles, and decimals. And the reason why we have different values or different kind of floating point things is generally because each of those has a different precision. So generally a float is only good up to 7 decimal points. It's only accurate up to 7 decimal points. Whereas a double it's either 14 or 15, and a decimal is 28. So that's kind of what that is. You won't have to remember this. I will generally never ask you to do anything with anything other than like an int and a float. So that's kind of what you need to know. And then we have things that are characters. Characters are single letters by themselves. They're the things that correspond to like an ASCII chart. So it's going to be A in single, and generally it's going to be single quotation marks. So A in a single quotation mark, or 1 in a single quotation mark set. Whereas a string is a collection of characters. So it's a special beast in and of itself. Because every program writes it differently, but basically what it does is it says, collect all these characters and make it into one thing. If you go back to earlier languages, if you go back to ASM, If you go back to MASM, which is machine languages, there was no such thing as a string. And so you had to write things out character by character by character. It is so much easier to do strings. Booleans. Those that don't know what a Boolean is, it's a true-false. And every language has a different way of writing them. And we'll go through that, but generally they write true or false. Sometimes it's capitalized, sometimes it's lowercase, but true or false. Although there are some string languages that don't take strings, the strings true or false, or the values true or false for Booleans, and they will take ones and zeros instead. And then pointers. So those of you that are programmers, the word pointer, or those of you who have heard the word pointer before, probably had a cold chill go down your spine and you went, oh no. So pointers, for those that don't know, point to a place in memory. And you can manipulate them by changing where they point to and then messing everything up. We won't touch them. You might if you find a tutorial and you go off of a tutorial for your assignments for your major games. But in general, we won't touch pointers. So you can let out a sigh of relief. Pointers are one of those things that even experienced programmers are like, I don't know how they work, but they do. They're not super complicated, but they can be. So arrays. Arrays are technically not a data type, they're a data structure. And they're about the only one that we're going to talk about. Again, programmers who have taken data structures know that there are a lot of other ones. But an array is basically just a list or a collection of things. A lot of times they have special functions attached to them, so you can do something like int count equals Fibonacci.length, which will return the length, so how many numbers are in here. Or we'll grab just the first thing, or we'll grab just the last thing. So the biggest issue with arrays, and the biggest issue with languages when it comes to arrays, is you have to find out whether it counts this first value as being in the 0 place or being in the 1 place. Because some, and those of you who've taken Java and C++ are used to it being 0, 1, 2, 3, 4, 5, 6. But, as we will see, some languages are like, nah, that's confusing. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So, welcome to learning multiple languages and it being worse than your high school Spanish class. Conditional statements. And this was another question that was on your programming pretest. If-else statements, if Boolean expression, and it's always going to be some sort of Boolean expression. So if this is true or if this is false, if this is greater than this, if this is less than this, if this is equal to this, if this is not equal to this, those kinds of things. If this key is pressed, do something. Else, do something else. And that's how those work. And sometimes, like I said, some of them are going to be if Boolean expression, then do something. Switch statements are generally thought of more of an advanced version of an if statement. However, if you ever want to make a room of programmers spin their tops and just rant for hours, ask them which one is better. If-else statements or switch statements, or which one is more efficient in a language. Everybody has their own opinion, and that's an argument you don't want to be in the middle of. So, yeah, it'll cause meltdowns. But basically what you do is you kind of take this switcher thing, and then you set up whatever this number is, and you say, hey, I want to take this value. If this value equals case 1, so if it equals 1, then do this thing. If it equals 2, do this other thing. If it doesn't equal these things, do this other thing. And this is great, so it's a faster way of doing multiple else statements generally, but it also requires you to do some breaks and continues and things like that. So it tends to be more of an advanced. So if else statements are great. And generally what you're going to find, if you can do if you can program with one of these, an if-else statement, a for loop, a while loop, a do-while loop, a for-each loop, you can do it with the other ones too. It's just a matter of work. So find the ones that work for you, that you understand, and you do you. So loops. We have a for loop, and this was one that, again, was on your programming pretest that a lot of you don't quite understand. And this is okay, because for loops are probably one of the harder ones to understand because it's the one that looks the least like English. So all a for loop says is you need to declare or get a starting point. So that's int a equals 0. And then you need to say while something is happening. So in this case, while a is less than b. And then you need to tell it what you want it to do. And for some languages, you can only increase. For some languages, you can decrease. For some languages, you can multiply. For some languages, you can do completely other things. But so all it says is while a equals 0 to begin with, while a is less than b, do the thing in the loop and increase a by 1. And it'll keep going through until a is greater than b. So a while loop works in kind of the same way, and it's going to be while not done, so whatever you want to do. So while a is less than b, do the thing, and then at the end of the loop you'd have to add your a++. So that's all that is. And there's variations, there's do whiles, and so do whiles, the reason, or what do whiles, the difference between a do while loop and a while loop is a do while loop will always execute once, whereas a while loop doesn't have to execute once. So maybe you have a value that's like a is equal to 10 and b is equal to 10. And if you said while a is less than b, do the thing, add 1. If you did that in a while loop, so 10 is less than 10, it's not going to compute, and it's just going to drop out of that. Where if you had a do while loop, you said do the thing while a is less than b, it would do the thing before checking if a was less than b. So you would always do it once. And then a for each loop tends to work with arrays. And that tends to be, for each thing in the array, do this thing. And it just iterates through the array. And that's all it is. And again, we'll go over these in more depth for each of the languages that we're working on. So, yeah, and this 100% you guys have access to all of this. So please don't feel too overwhelmed, because I know it's a lot of information. That's what this class is. It's a lot of information up front, and then you're left to flounder and kind of work through it. And we'll work through it together. So operators, arithmetic, this one, apparently no one ever showed most of you how to use a modulus operator. Modulus operator, or modulo operator, is sort of like division, but it's not. What it does instead, it says, hey, divide these two numbers and then return whatever remained. So 10 modulo 3, you go 10 divided by 3. Well, we know that that's 3.33333. So we know there's going to be 1 remaining. So the answer would be 1. 8 modulo 4 would equal 0, because there is no remainder. 15 modulo, I don't know, 2 would give us a 1. Whereas 15 modulo 4 would give us a 3. So that's how that works. It's just asking for the remainder. Relational is what we talk about when we talk about comparing things. So when we have a single equal sign is an assignment. A single equal sign says, hey, this equals this. So A equals 10, B equals 7, C equals Bob. You use a single equal sign. When you're trying to check and see if something equals to each other. So A is A B? So does the value, or does A have the same value as B? You use a double equal sign. The second one, the exclamation point with the equal, it's a not. That's the not operator. So does A not equal B? And then we've got the greater than, the less than or equal, the greater than or equal. I am not going to touch bitwise because y'all shouldn't have to mess with bitwise operators. Those of you that are programmers, you may have fun with those. Most people do not. Logical operators, however, tend to work hand in hand with your relational ones, and those are saying, so if you have an if statement, and you've probably seen this, if this one thing is happening and this other thing is happening, if this one thing happens or this other thing happens, so that's and, or, and not, just like we had here. This is not. An assignment, equal plus equal, like, yeah, an increment and decrement. So this just means add one, subtract one, add at the beginning, subtract at the beginning. And yeah, you'll use these two, but probably not those two, at least for this class. You will use at least these guys. Maybe the modulo operator is actually really fun to use for things, but it's not often a thing that people like automatically use. You'll probably use most of the relational, and you'll use the logical, because one of the things that the logical is really good for is when you're saying, hey, maybe you're making a keyboard controlled game, and you want to make sure that if somebody's pressing the W key or they're pressing the up arrow, so you'd have, if W is pressed or the up arrow is pressed, or maybe you want to make it only happen when you press Control S. You would say if the Control button is pressed and the S button is pressed, do the thing. So we already kind of talked about this. Assignments, it's just assigning a value. Functions and methods. So I will use the term function and method interchangeably. Technically, they're different things, especially in non-English languages, but we won't worry about that. So they're basically mini function or mini programs inside your program. So the routines that can be executed, they provide functionality. They generally have some sort of parameter list, and they generally have, those of you who have done Java and C++ maybe not have seen as many return statements, but generally they have something that they return implicitly or explicitly. And again, we will talk further about this when we actually get into talking about each individual language. But yeah. So are there any questions about what I just went over? Okay. Yes. Modulus operator. So that's just going to return your remainder. %, 4. It's going to be 0 because it doesn't return anything, or it doesn't have a remainder. So think about when you used to do like longhand division as a kid, and you would have like this one remainder, so like 10 modulo 3. So you would put 3 into 10, and you know that 3 3s go into a 10, but you have this one thing right there. And so generally when you do long division, you'd put that decimal point down and you'd add a 0, and so then you'd go 3 goes into 10, and you just get the repeating 3 over and over and over again. What modulo says is, so we know that 3 3s go into 10, and we've got this one funky guy hanging out on the other side. We want to know about that one funky guy. So all you do is you return that 1. Does that make a little bit more sense? Okay. Yeah, they're one of those things, like, people either love them or they hate them. They can be, like I said, they can be really helpful when you're trying to figure out or randomize things. Or if you're trying to figure out if something is even or odd. If you divide any odd number by 2, it's always going to return a 1. If you divide any even number, or, okay, as far as the modulo, there, it's always going to return the 1 because there's always going to be one remainder for odd. And if you do an even, it'll always be 0. So that's where that's really helpful. Okay, cool. So, with that said, I know today is going to be a lot of different things and it's going to like switch between a few different things, but I wanted to get some stuff out of the way. I'm not sure how many of you are here to be business people. I'm not sure I'm not sure how many people are here for what. So, we're going to talk a little bit about project management. And I will slowly go away from this and it'll just be like homework stuff as far as project management stuff goes. Because project management is such a weird beast. It works differently for different companies. And you've got different styles, which is going to be part of what your homework is tonight. So project management. There are generally about 5 phases in project management: initiation, planning, execution, controlling, and closing. So you will have a quiz on this document as well as the programming stuff. But again, it'll all be open notes. Yeah. I'd much rather you guys know where to go find your references than like actually memorize things. So, and this is defined by the Project Management Institute and the Project Management Body of Knowledge, which is actually a thing. Who knew? So, the cycle. It's not linear. Like, when you look at it like this, you think, oh, 1 to 2 to 3 to 4 to 5. But the reality is it's not. You start at initiation, you go to planning, you go to execution. If things are all great, it goes directly to closing. However, if not, you go planning, execution, controlling, back to planning, back to execution, and you just get stuck in this kind of center wheel. Eventually you get to closing, but that doesn't mean that you're not going to circle this like 800 times. And in game development, you do. You really, really do. You go from planning, figuring out your basic GDD, those kinds of things, to execution. You make maybe a first level. You control it by doing tests and making sure it works. Then you go back to the drawing board to make sure that you can implement all those things, and then you go back to execution, to controlling, to planning, to blah, 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 blah. And it just keeps in a giant, vicious cycle. So initiation, that's concept development. So what project should be done? What should be accomplished? What are the overarching goals? Scope is really important. Scope is not only talking about money, it's also talking about time, who is it geared for, the type of people that you're going to need. So for big companies especially, when we talk about scope, we say, hey, how many people do we need to pull off of other projects to do this one project? Like, how important is it? How big is it? Who do we need? What do we need to make a minimum viable product? So other expectations. So like, what does your management want from this thing? What does the customer that is hired you to do this want for this thing? And then other parties. For games, a lot of times that works down to management. So those are the people who are like in charge of you. And then the customer is actually whoever has given you the idea, or maybe it's your parent company like 2K. And then other parties are often what we consider customers. So maybe, you know, Gearbox is making Borderlands 4 for lack of a better experience, or lack of a better option. So management wants one thing. They want this game to work this way. The customer, so 2K, is like, yeah, we like what you've done with Borderlands, but we want to take it in a new direction. We want to make it into an MMO. Which they did, by the way. Borderlands had a Chinese MMO. It was weird. But the other parties would be, say, maybe your normal consumers, so your fans. And there's a lot of fans that are going to be like, whoa, I don't know that I like this. kind of like the way that you saw Fallout 76, which, by the way, if you see my desktop, I do have it on there. I do actually kind of enjoy it. Yeah, you can make fun of me all you want about that. But so that's actually a really good example. Management wanted an MMO. Our management wanted one thing. They wanted a new Fallout game. Customers, so 2K was like, hey, MMOs, not 2K, Bethesda, was like, hey, we want an MMO, because MMOs are like the big new thing that everybody's making, that everybody is great. And really what your customers, what your general player base wanted, they didn't want an MMO. They just wanted something that they were able to play with their friends. They wanted a multiplayer, a co-op experience. So in that kind of thing, honestly, I would say that Fallout really failed, especially 76. It really failed to deliver what everybody wanted. Yeah, it delivered the whole MMO type thing, but not really, because it's not, like, it's just, But it definitely didn't meet the expectations of other things. Yes, it's another Fallout game. And especially now that we're seeing NPCs, like human NPCs that have been introduced, there's definitely more of a storyline. It definitely feels more like a Fallout game. But there's still a lot of people who are really let down by this experience, that all they really wanted was to be able to play with like 3 or 1 of their closest friends and run through the wasteland shooting things and using console commands to get unlimited ammo. So initiation, like, this is probably one of the most important things, because you got to come up with all the ideas, you got to come up with the scope, you got to figure out what you need and what you want. You got to figure out overarching goals. So this person wants this thing, this person wants this thing, this person wants with this thing. How can we make all of those mesh together? So planning. Again, that's refining your scope, and it's going to look a lot like your initiation. It's refining your scope. It's creating task lists that say, hey, you need to make this, you need to make this, you need to make this. And this works great for things like Game Sim, where you need to make definitive lists for each department. You need to write this script, you need to write this script, you need to write this script. And then for artists, you need to make the UI, you need to make the background, you need to make the character, you need to make the enemy, you need to make the floor, you need to make... So you know everything that needs to be done. And then you sort and prioritize tasks. And this is also a great way to look for what we call feature creep. Feature creep is where you go from like your plan, and you have this solid idea of this is what's going to happen. But somewhere along the line, when you get into planning, you're like, ooh, but what if we added this? And everybody's like, oh my god, that would be so cool. And then you realize somewhere down the line that you're working on this entirely tangential, different project. So doing a really strong plan and task list will make sure that you're prioritizing the things that have to be done while pushing that feature creep to the back. This also helps when you're talking about creating schedules and budgets, milestones, assigning resources, external hires, figuring out who needs to do what, when it needs to be implemented. And that's a really big one when it comes to the game development cycle, because you have programmers who need things to work with from the art department, and art department needs to work things from the textures, and everybody's got to work from the sound, and you need the level designers to actually finish like designing the level so that the artists know what they need to do, so that the programmers need to know, and it gets into this giant kind of quagmire. And that's why things like gray boxing, which is building your level out of simple shapes that are approximate to your models, is so important when it comes to like big games. And Blocktober is getting ready to start, which will be like, you'll see a lot of people that are blocking out levels in all sorts of things, and big companies tend to do it too. It's pretty cool. So after you've had this whole breakdown and hash out and screaming at each other to make sure that everything is done, the last thing is that you've got to get it approved by management. Now, management may be like, we don't like this, and you may have to go back to the drawing board. Or management may have their own input and be like, we like this, but we want it to be an MMO. And so you either have to appease them, or tell them to shove it, or convince them otherwise. Sometimes it's easier said than done. Yeah. So what's the plan? There's 3 major components: the task list, your schedule, your budget. And this can be, for some people, this turns into, at least partially, part of your technical design document. When you start out a game development cycle, you tend to, and most people know what a GDD is, which is a game design document, which is a big kind of the holy grail of everything that's supposed to happen. And that's kind of what your plan is. But that gets broken down into things like the art Bible, which is used by the art department to make sure that everybody's following the same kind of flow, the same kind of style, the same kind of everything. In the same way, and this one is often overlooked because programmers are notoriously bad about doing them, is a technical design document. And a technical design document says, hey, this is how the code should look, this is how the code should function, this is the naming convention we're going with so that it's easy for you to figure out what variables to call from this person's script to this person's script. This is all kinds of things. So it'll also break down your task list, which departments are needing to do what, those kinds of things. And schedule and budget, which sometimes schedule is just as hard as a budget, because really you have to figure out how hard you can push somebody before they break. How hard do you want to push somebody? Because unhappy workers produce bad stuff. Like, just point blank and simple. In the same way that workers that are terrified that they're going to be fired for making a mistake produce mediocre to awful work. So you have to budget, you have to kind of plan this stuff all out. So work plan, which we've kind of already talked about, break things down for members and departments and things like that. Create milestones. And milestones are like mini victories. They're mini achievements. Those of you who have heard talks about scrums or heard talk about agile development, there's this huge thing where you run in sprints. So you have 2 weeks of tasks to do, and you try and get all these tasks to do in 2 weeks, and that's kind of your first thing. But then you have like 3 sprints that work up to 1 milestone. So your milestone may be something like finish level 1, or have first open playtest, or things like that. It's things to work towards, because the way that our brain works is that we like having goals. We like when we can pat ourselves on the back. When we can't see an end in sight, we get sad, and it just drags us down. So by breaking things up into smaller goals, milestones, you have continuous pats on the back, or continuous you need to reevaluate the way that you're working so that you can meet the next milestone. It's like dangling a carrot in front of a donkey. It's that kind of thing. Execution, development, do the things. So project managers, on the other hand, while everybody else is running around like chickens with their heads cut off, arting and developing and programming, project managers have even more to do. They lead the teams, they make sure everybody's on task, they meet with team members individually generally as well, you make sure that everybody's doing, you manage the milestones, so if it looks like you're not going to make it or something, maybe you push it back by a day or two. You communicate with the stakeholders, so these are the people who give you the money, so you have to make them happy. You also put out fires, and then maybe Jill and Janice and another J name, let's go with Juanita, for whatever reason, all decide that they're going to get pregnant at the same time, so suddenly you have 3 people on maternity leave, and maternity leave you have to pay for a certain amount of time, but you can't just stop. You need somebody to take their spot, so you secure any unforeseen kind of money. Maybe now that means that you're going to have some sort of daycare service, so you try and figure out how to manage money to get stuff like that around. And that's kind of an extreme example. Other things can happen that you need to do with that kind of stuff as well. So control, again, this is development. This is going to be a super important one. I'm going to mention this probably a lot of times with you guys. Feature creep is a thing, and it will sneak in at the worst possible time. Both artists and programmers are really bad about it. So artists may suddenly find themselves, ooh, what if I added this detail? Or what if I added this tiny little thing that nobody is ever going to see? Like, let me texture every small fiber on this dress. And while that's cool and all, and that would be great, maybe the rigging department needed this model, like, or the animation department that's rendering like cutscenes and things like that, they needed this model with this texture 8 days ago, and you're not even a quarter of the way done with the texture. So with programmers, it tends to be, what if I change this program entirely and I did it this way instead, which means I've got to scrap everything I've written and rewrite it from the ground up. Or you're like, hey, what if I made this AI work like this? So taskmasters are, yeah, you're not always the nicest person when you're a project manager. People love and hate you. Yeah. So again, reschedule, manage your budget, monitor and adapt as the project changes and evolves. A good example was my studio, we started working on a project that... No, we don't need my consent for anything. We started on a project that was a PC project, and we got about 3 months into it and realized that it was much better as a mobile game. So we had to really change gears and work on it for a mobile game. And yeah, if we kept working on it for a PC game, it wouldn't have been as nice of a final project. Definitely better. And we had to communicate with the person who had actually hired us to do the gig. So we had to convince them that what they wanted and what they were making would be better served as a mobile game, which we did. And that's not always the project managers. Sometimes it is. In the company that I work for, we've got the guy who's the head of us is the project manager, and he tends to be the person, he's the face of the company. He's the one that everybody wants to talk to and is very nice. I'm the one that yells at everybody and tells them to get back to work. So, and that works for us. Some companies are worked like that, some companies are not. So, closing. After everything is done, you should always have some sort of postmortem. This goes for GameSim. GameSim, you will have to have a postmortem, and postmortems can get ugly. They can get ugly really fast. They can be really nice, they can be really sweet. It can be a giant love fest, congratulations, we did it. But there will always be some sort of finger pointing about, somebody will be angry about something that happened. This happens with game sims more often than not. Game sim postmortems are either the most anticlimactic things because everybody is just so tired and done with seeing everybody's face, or everybody, at least half of them are happy and half of them want to murder each other. I know from experience. Yeah, so as a side note, I did go through the programs that you guys are going through. The only class I have never had from NBC as far as the game development and 3D animation courses is the digital sound class. So, I was there. I know how GameSim works. I know how Scott works. I had other professors, and some classes have changed the way that they work, but I get it. I know what you're going through. So, and yeah, I can commiserate. Yeah, Scott can be that's yeah. He's a great person who I still, every time I hear somebody whistling down a hallway, get cold chills on my back and have to look and see if he's there, even if I'm not at school. And And especially now that even though we're coworkers now, it's, yeah. I learned a lot from him, but he's also terrifying. So yeah, so postmortems are important. You review the process, you make sure, what was learned, what wasn't learned, those kinds of things. So reasons a project might fail, and the reality is that projects fail a lot. And a lot of times it comes down to not having enough planning or not actually setting out a clear plan for what you're doing. And that's why things like a GDD, a TDD, an art Bible are so important. Because when you have a concrete plan to follow and to go towards, it's easier to at least, even if you find yourself halfway through like hating it, if you have a plan, you can either change the plan or you can follow through to the end. If you don't have a plan and are suddenly letting this thing morph and evolve into something that it never was or never was planned to begin with, there's a good possibility it will never end. Disagreements, and this can be things like you lose the money because your stakeholders decide that they don't like what you're doing, or they don't like the way that your team is handling it, or it could even be that your art lead and your programming lead hate each other, and so just stop communicating entirely. Like, all of these things can cause a project to fail. And there's a lot of other reasons it can cause. Like, it's always on your mind. Is this project going to work? Is this project going to fail? And then there's a lot of projects that just don't have a concrete enough idea. And so they get stuck in the planning phase and they just keep going around and around and around. With game development, there's a lot of things that get stuck where you make a prototype or a proof of concept and then they never go anywhere from there because you just decide that that's not a thing. So that's it for project management. Does anybody have any questions on that? Okay. So, we're going to talk about pseudocode. And this is going to be fine. Those of you who can't code, those of you who feel like, I can't code, nothing I do, pseudocoding is one of your best friends. If your intro professors didn't talk about it, I'm sorry. But we'll go over it. Pseudocoding basically is writing code in English before you even get to a programming. And for some programmers, they think, pseudocode is a waste of time. And it can be for smaller programs, but for bigger programs, it's great. So, a logical, informal, and high-level description of what and how you want to code to work, usually without thought to what language it will be built in. So basically this is saying, I want to write out what this program is going to do and how it's going to do it step by step without actually writing code. Yeah, like a blueprint. And this can be particularly helpful for you guys as project managers because it means that you can say, guys, this is how I think the code should work, and you can take it over to a coder or one of your programmers, and the programmers can be like, okay, now I understand exactly what you're wanting this program to do. Because sometimes when you give an idea to a programmer, you're like, hey, I want this to do this. They're going to write something that, yeah, it works, and yeah, I guess it does what you asked them to, but maybe it doesn't work in the way you wanted it to. So by writing out pseudocode or even being able to think in pseudocode, you can better help your idea be understood to programmers. And programmers who write pseudocode tend to be more efficient at what they're writing because they've already thought about all the variables they need, everything they need. And what's great is once you write a good pseudocode line, you can translate it into any language. So why not just write the code? Again, like you said, it's a blueprint, or think of it like a prototype or a mock-up. When you have those small programs, it may not seem like it's worth it, but it's good to think about it on the smaller programs because then it helps you think about when it comes to bigger things. So, like, you're not just going to automatically go into coding an entire defense system and, you know, crack your knuckles and, like, okay, here we go. You're going to have some sort of plan, some sort of structure, some sort of a plan. Yeah. And so, when it comes to that, other things that happen, or other things that get used that are more programmer specific, are things like flowcharts, UML diagrams, which you may or may not have done if you took a Java course, and Dracon charts. Of those, the one that I've seen the most often, especially for bigger programs, are going to be UML diagrams, and those are just fancy flowcharts. They really are. And it's just a different form of pseudocoding. So, the easiest to grasp, especially for non-programmers or people who have no desire to program, the idea of being able to just logically write out step by step what's going to happen is a lot easier. So, rules for pseudocoding. There are none. There really are none. The only thing that you should do is you should make sure that it can be read, by a human. Some pseudocoding starts looking like code, and that's okay, but generally you want it to be in such a way that you could give it to, like, your middle school aged sibling, and they'd be like, okay, yeah, I know how this is supposed to work, without them having to have any experience in coding. So there are some specific standards for certain languages. Fortran, Pascal, C, and Structured Basic all have, like, guidelines for pseudocoding, which then makes it look like code, and that defeats the purpose of a pseudocode. Yeah. So, we've already kind of talked about these. Feel free to use, you know, the equal sign, the plus minus, the modulus operator, the logical ands and ors, all of these guys. You know, it's to you. The arrow is just another way of saying this is to this, or this is equal to this. Whatever works for you, whatever floats your boat. As long as I can read it and you can read it, we're all good. Keywords. The following, these words are helpful. They give you kind of an idea of how to get started or what you should be looking at. You know, start by doing whatever, or start. Input. This is the input that you're retrieving. Read and get. What input is being used. Print, display, show, output. Log, for those of y'all who are Java, that would be like printf or printline. For those of you who are C++, that would be like cout. Compute, calculate, determine, set, or initialize. And we do abbreviations, so init is fine. Increment, bump, decrement, increase, decrease. You know, all of those words. These are just helpful words. You don't have to use them. If these words don't make sense to you, these words aren't good for you, don't worry about it. If, else if, else. So, when it comes to pseudocoding, while there is no, like, definitive structure, tabbing or putting bullet points or numbering is helpful. And if you're going to do loops, if you're going to try and write a loop, the suggested kind of way is to have something, is to capitalize things, and to have something that says, hey, end my if statement. And we're going to see with things like Lua that you actually have to write this kind of stuff inside the code. The reason why we start with Lua, well, we start with DOScript, but the reason why we start with Lua is because it is going to look remarkably close to pseudocode. It is probably one of the most easy to read languages out there. So, if you want to use it then. If you don't, you don't. Just, you know, write it the way that feels good for you. So a game loop example. So set up initialize. That means, you know, start the game. While game is not over, get the user input, update the variables, draw to the screen, clean up. This is incredibly simplified. Like, this doesn't tell us what kind of game or anything. This is just the way that the loop would work. So, we can either, well, we'll look at the example. So I have this whole thing, this idea of a paycheck pseudocode. So calculate your paycheck at the end of the week. The user inputs the hourly pay for the day. The user inputs the number of hours worked for that day. And then you keep getting input and adding until the week is over. So 7 days. So print the total amount. So to write a pseudocode like that, it may look something like this. And this is actually closer to code than generally I would like it. But, so declare an integer variable for pay for day. Declare an integer variable for the number of hours you worked. So, how much are you paid per hour? How many hours did you work? Declare an integer variable for total pay. So this is going to hold the entirety of, this times this. And then declare the Boolean variable done. So while you're not done, so while you're still taking input, pay for day equals the user input. So how much per hour are you getting? Number of hours is equal to the number of hours that you put. So your total pay is now your total pay, so the previous amount from doing this, plus your daily wage. Prompt the user if they're done. If the user says, yeah, I'm done, then done equals true, and we fall out of this not done loop because it is done, and then we print the total pay. If they say, no, I'm not done, it goes back to the top of the loop and continues on. Does that sort of make sense? No? Okay, so an easier example would be something like so basically if you are wanting to get an even or an odd number, you're going to flip a coin or you're going to roll a dice and you're going to print out the number that's on the dice. So you would say, hey, I have a dice, or I have a die, and I need to print the number. So those are the two things that I need to do. So step 1 would be roll the die. Step 2 would be check the side. And step 3 would be print the number. That's it. It's just like working things out step by step rather than writing it directly in code. So for something like these, a character heads down a corridor and checks each movement if there is something in front of them. If something is in front of them, it checks if it's an enemy. If it is an enemy, attack. If not, help it. Then end a turn. Or then at the end of the turn, the player chooses to heal or continue. So the first thing we have to say is we know that we have a character walking forward. So we know that we need to be able to check input. So we can say, hey, we know we need input. So like the first thing that you want to come up with is your list of variables. So the list of things that you know are going to happen. So we know we need some sort of input. We know that we need to check if something's in front of us. So maybe we have a Boolean that says is in front, or is empty, or is full, or whatever we want to call. Then we know we need to check and see whether it's an enemy or if it's friendly. So maybe we say is enemy. And then we need something that tracks our health, because if the player dies, they lose a heart. And we know we need something to track how many enemies that we've fought. So we come up with our variable list, and then maybe we write our steps. So like step 1 would be move forward 1 space. Period. Check if enemy in front. Period. If enemy, attack. If not enemy, heal. Like, it's just, you're just breaking things down into step by step by step. Does that make a little bit more sense? Like I said, this, I'm not 100% sold on this being an example. I meant to change it before this class because this is an example from the professor that taught it before me, and maybe from the professor that taught it before them. So this works for programmers, I'm sure, but for those that aren't used to thinking in code, this still looks like code. So 100%, if you want to make it into a numbered list or a bullet pointed list, do it. If that's going to work better for you, do that. It's just the steps that you need to do to make it into the thing. And I always suggest declaring your variables up at the top, because what you guys are going to do with this stuff that I have for you guys to work on is that you're going to write out some pseudocode, some very small pseudocode projects, and then for both Lua and Python, you're going to take that pseudocode you wrote and you're going to translate it into Lua and Python. So it's meant to see how your brain works logically, and then when you go to code it, if you have to fix anything because you find flaws in your pseudocode logic, that means for the next time you know how to change it. So yeah, so that's kind of what I had to say about this. Controllers are a lot harder to pseudocode. It can be fun, but it's a lot harder. Doing game loops and figuring out how your game is going to work is definitely the most helpful, but it's not the end all to be all. So that's kind of my introduction to pseudocode. Did anybody have any questions about that? Like, the breakdown is, it's just the logical steps to get from point A to point B. Okay, so at this point, I actually got through this a lot faster than I thought it was, and I think that's because we didn't have to do introductions. You do have a class assignment, and what this is going to do is you're going to write pseudocode for the following. You're going to take the user input and convert all the letters to uppercase, print out as a result. And that can literally be as simple as ask user for input. Make sure input is letters. And then you can say convert to uppercase, because every language, pretty much every modern language, has a function that will convert to uppercase for you. You don't have to go into your ASCII charts, and I'm not asking you to go into your ASCII charts and figure out the difference between a lowercase a and a lowercase b and changing it that way. That's a Scott thing. I won't do that to you. So it can be something as simple as that. Get 2 numbers from a user and add them together. Print out the results. Now, one of the important things to remember with these is that your user is somewhere between stupid and conniving. So you always want to make sure that you error check. You want to make sure that you take user input and convert, or get 2 numbers from the user input. Well, you want to make sure that 1, they haven't left it blank. 2, they are numbers. So just make sure that you're error checking. So it would be something like, you would declare number A, you would declare number B, and you would declare sum. So those are the 3 variables that we know we need. And then you would say something like, ask user for first number. Check if input is a number. If not, ask for number again. And then the next thing would be like store in number 1. The next thing would be something like ask user for second number. Check if second number is actually a number. If not, re-ask for number. After that's done, store in number 2. And then the third thing would be print. And you could either do the sum first, so you could do sum equals number 1 plus number 2, or you could just say print number 1 plus number 2. So something like that. Get an unknown amount of numbers from the user and then add them all together. So this one gets a little bit tricky because what you have to do is you have to like keep a running sum, which is my suggestion. You don't need like number 1, number 2, number 3, number 4, number 5, number 6, etc., etc., etc. Just have a sum. And you're going to do pretty much the same thing that you did. Ask the user for a number. They'll give you a number. Then ask them, or make sure that that's actually a number. Then you're going to ask them and store it in like maybe a temporary variable. So maybe we have a variable called sum and a variable called temp number. So then you're going to ask them, so you'll ask them for their first number, you'll make sure it's a number, and then you're going to ask them, hey, do you want to give another number? If they say yes, then you ask them for the next number, and then you just add that into the sum. And add it into the sum, and add it into the sum, and add it into the sum, until they say, no, I don't want to add another number. And then you just print out whatever sum is. For print out random numbers until the user presses a certain key, every language has a random number or a random generator. So this is not something like I'm meaning it to be crazy. You can literally be print a random number. Ask a user to press a key if they want to continue, or any key to continue, or this key specifically to stop. Because that one can work a little bit differently. It can either be that it just continues to print like in a loop until you press something, or it can be a prompt kind of thing. Getting a random number, again, it can literally be that step can be get random number. And then if number is even, print right. If it's odd, print left. So for that, this is where your modulo operator is really helpful. Because like I said, if you do any even number modulo, so that's your percentage sign, 2, if it equals 0, it's even. If it equals 1, it's left or it's odd. So for this one, you're also going to have to keep some sort of running track for left and right. Now, there's an added issue with this. How does your program compute a 0? For some programming languages, 0 is neither even or odd. For some programming languages, 0 is even. So it just kind of depends on what you're doing. It really depends on the language. So you may want to add in another conditional statement that checks and sees if the answer that was printed out was 0. And again, if you're printing out random numbers, that doesn't mean that you have to print out all positive numbers. That doesn't mean that you have to print out decimal numbers. That doesn't mean you have to print out integer numbers. But you're going to want to say what kind of numbers you're wanting to print out. And since we're doing odd and even, you're probably going to want integers. They could be negative and positive, but it's going to be up to you. So are there any questions on this assignment? Okay, so 100%. Y'all can work together. Y'all can talk about it. I would prefer that you not Google the answers because the answers are out there. They really are. But I just want to see how you would logically make this kind of stuff. The other assignments that you have, well, okay, so the first thing, let's talk about this. This may or may not be helpful for this current situation, but for some of your other classes it may be more helpful than this class. However, when you go to build games in this class, I will never ask you to make your assets. I will never ask you to draw everything. I will never ask you to make sound. Ripple.it doesn't work with sound, as a side note. My suggestion is to always go find a place. Work smarter and not harder. Like, let's be real here. This class for a lot of you is probably a throwaway class. You don't really want to be doing this. It's not something that you really want to put the effort into. So find these places like KennyNL or Open Game Art that's going to give you free art to use and use it. This goes for a lot of other classes too. Yeah. So we will only be dealing in 2D, but I've also got some stuff for 3D, some alternatives to Unity. None of the things that we're using are actually on this list, but yeah. So the other things that you'll have to do as far as homework goes is you're going to research at least 3 project management tools, and you're going to answer some keys. And this can be anything that you think would be a project management tool. This can be Trello, this can be GitHub, this can be Bitbucket, this could be things that are for like task managing. It could be Slack, it could be Discord, it could be whatever you want to do. It could be Hack and Plan, it could be yeah. So you can literally just type in project management tools, or maybe project management tool for version control, or whatever you think is going to make a project management tool. And I'm not meaning to ask like crazy long explanations for anything. These things aren't meant to take you a ton of time, just some time. And yeah. Because project management tools can be just about anything. It can literally be Unity. It could be Unity Collab. It could be a management software. It could be a timekeeping software. It could be something that has flowcharts. It could be UML diagramming. It could be any kinds of things. These are some links that are helpful. I will never check to see if you read these. So if you don't, if they're interesting to you, read them. If they're not, do. This might give you, some of these will give you some ideas for where to look for project management stuff. So yeah, this will be a discussion board. You'll need to respond to a classmate. So project management certifications, don't take so much time on this. This is like a required assignment, so just look at this kind of stuff. What's a PMP? What's a PMI, ACPO, or a CSPO? Write, a few sentences for me on each of them. So these aren't due next week. These are due in a couple of weeks. And this is create a pseudocode. So this is going to be like your bigger pseudocode things. So these are bigger projects. So create a pseudocode for a number guessing game. And these are the things that it's going to have to do. And then you'll also have one for a thermostat. And so that's going to be the end of like our first week together. As you can tell. So yeah. And again, if you go to the calendar is really helpful. I'll turn off level design. And you can see how I have things due. There will be a quiz on programming, so the programming thing and the project management portfolio. Yeah, totally. PowerPoint. It is 100% open note, open book, open ask me questions. They're due at the beginning of class. It should be open. When does it actually open? It's open now, so if you want to take it while it's still fresh in your brain, go right ahead. I will wait and reopen the quiz probably this afternoon, the pre-test quiz, so that you guys can retake it. And next week we will be looking at DOS scripting. Again, if any of you has a Mac that does not run Windows, please let me know, because that's what we'll be working on. Maybe, I'm still not 100% sure. I didn't mind as much when we were working on the school computers, because if you mess those up, it was their problem to deal with. So I may show you some stuff and not make you actually do anything with DOS scripting. I don't know. Because DOS scripting can really mess your system up if you do it wrong. Okay, so if you have a Mac, does it have Windows on it, or is it just all Mac OS? Okay, so you won't be able to do DOS scripting unless you get a VirtualBox, and I don't want to make you do that. So you'll just follow along next week, and for any assignment that's due, you can tell me you have a Mac, and that should be fine. Because I do want to show you, because it's technically part of the class, is that I have to show you DOS scripting. And DOS scripting can be really cool. It can be extremely powerful, to the point that you can brick your computer with it. Which again is why I'm always hesitant to do it on personal systems. But your computer should have some fail-safes on it to stop us from bricking it. So, yeah, so if anybody else has a Mac, just let me know and we'll deal with it. Unlike Scott, I like Macs, so it just makes this part of the class harder. So I may come up with an alternative for us to do. I don't know. We'll see. So we're either going to do DOS scripting or we'll do something else. Or we'll do a little bit of DOS scripting and switch it over to something else. Because I at least want to show you things like how to write a matrix program. So that's a program where it prints the numbers out exactly like the matrix, like the matrix screen with all the numbers going crazy all over the place. And that's a lot of fun to do. Yeah, that's a lot of fun to do. So, are there any other questions? Concerns, desires, needs, wants about this class, about the university, college, about what to expect or timeline? Anything I can help with? Okay, so as you can tell, it's 11 o'clock. This class, I don't tend to run the full time frame, only because, one, it's 9 a.m. and generally if I'm in class, I'm having to wait for like an hour for people to show up. But because we're all on computers and we can just roll out of bed and log in, life is nice. But it's also to give you guys more than enough time to work on assignments. This class, I never want this class to be the one that you guys are stressing about. You will, inevitably, because you're actually building games, but a lot of the time will be lab time for you guys to work during class. And I say this to people when they're actually in my class and not online. I don't really care what you work on. I just want you to use the time to your most advantageous or best, however that is. Does that mean going back to sleep? Sure. Does that mean working on a modeling project or your portfolio work or maybe something else? Yeah. Y'all are all grown-ups, all adults, and part of figuring out how the world works is figuring out time management, and sometimes that means shoving the class that's not as important to the bottom of the barrel and working on other stuff during that class. And I get it. So, since there are no other questions, I will be around until 12:30, probably, unless I conk back asleep. So if you do have questions or need to get a hold of me, yell at me in Discord, send me a message. If you type the @ symbol and my name, or it'll come up with a list, you can ping me, so it will like automatically send a message to my phone and say, hey, this person needs you, like I've been doing. Or that works too. @professor works as well, because I set those up. It'll ping me, and so I'll be able to see it. It'll give me a notification on my phone. It's, again, or if you want to talk to me privately, if you right click my name or I think it's double tap on the mobile, it'll bring up an option to kind of do a private chat with me if you would rather that option. Either way, I don't care. I'm all good for that. Or if you, again, like talking to me better in Canvas or through email, that's fine as well. It's up to you guys. So yeah, so now that it is 11 o'clock, thereabouts, be good, have a wonderful day, have a wonderful weekend, try and get the work done that I have set up for you guys to do. I think the in-class stuff is due tonight at midnight, but again, if it doesn't get in at midnight, I'm not going to be heartbroken. Yeah, it'd be nice because then I can grade it faster, but it's kind of up to you guys how fast you get it done. Yeah, this class, I don't like 9 a.m. classes on any day. And yeah, I don't like 9 a.m. classes on any day. So, and it being on a Saturday, I know this is the day that everybody wants to sleep in. Yeah, the person who taught it before me, they love morning classes, early morning classes. They tried to teach a 7 a.m. class one semester, and I don't, mm-mm. So, okay, so with that, have a wonderful weekend. Again, I record everything, so I'll process the recording and put it up to an unlisted video on YouTube, and I will link everybody. So, with that, I'm going to stop screen sharing. If I click the right button. And I'm going to disconnect from voice. Let me know if you need any help. And yeah, I'll talk to you guys next week.